Hello and welcome back. Okay, now when I was running this before we had a few problems and I did say I was going to come back and try and troubleshoot it. So I've taken the board away and I've done a small video in between. So now I've brought the board back and let's take a look at it. Okay, this is actually behaving itself now, which is a little bit odd. Now in some ways that worries me even more because intermittent problems are the worst to track down. But it also carries the implication that nothing's too bad. Now I can clock this really fast by taking this capacitor out. This looks like it's working correctly. Most of the problems we had we saw towards the end, so maybe we could update the code and check that. That could be a random character in the L slot, but I'm not seeing any strange response on this register anymore. Ah, yeah, so we are still seeing occasional problems, but that does give a stronger sense that maybe this is just a loose connection. I don't know what I'm going to do. I suspect running it very fast may be the only way we see any frequency of the issue cropping up. If I put a longer string in there, we might be able to see it a bit better. Right, so hello world without the 0 is 12 characters long. So that'll be 25 characters with a space. It will wrap around oddly, but we should be able to see it a bit better on the screen. So that should be 40 characters. Put a few more knops in here. Okay, that's a bit more wrong again. Alright, let's start checking the wires. Okay, I'm getting a lot of difference over here. This has gone nuts over here as well. Okay, we're still seeing oddness on this board here with that completely disconnected, so it's not the whole of the problem. But something's not right. I do have an unused gate over here. I could try bringing those inputs low. That power's not a very good connection either. Alright, think about this over here. Right, actually, instead let's break this down and think about what could have changed. Why it could have come loose, but I've done quite a lot of checking since the last video. We added the transfer register board. Now, we do have this other thing where I disassembled all of this in order to update these backplanes. So these boards could have gone back on in a different order. I haven't really been tracking that. So that might be worth investigating. The changes I made on the back of these boards could need to be double checked. I'm going to start with the transfer register. Got here the original prototype transfer register, and we should be able to wire that back in quite easily. Right, so that was memory bus. This I think was the transfer bus, and then that would be main bus. Assert main for TL. Assert transfer. Assert address. I think that was load TL. And that would be TX load. Alright. Okay, that's slightly worrying, but we've seen it act correctly before. Okay, so without this board in place it works. With this board in place we get erratic behaviour on the board even though everything this is doing seems to work. Well, that's frustrating. So this is either an error soldering it or a mistake in the board design. Now, I figure the thing that's most likely to cause the kind of instability problems we're seeing is going to be floating lines. Actually, that looks like it could be a solder bridge. I'll get the soldering iron warmed up. Seeing that. Now that's on the latch chip for TL. Okay, let's keep, okay, soldering iron's warm actually. Let's get rid of this solder bridge anyway. Looks like the end of that chip is very slightly lifted, which made it a little bit more difficult to get all the solder connections good. Okay, I just want to take a look at what the implications of that solder bridge might have been. So those two lines were output enable and D0. Let's have a quick look at the PCB design to see what D0 was actually connected to. Sometimes I reverse the order of those bits to make the PCB layout easier. Okay, so that is actually data 0. This would have only caused a problem if data 0 were high because output enable is tied to ground, and in the test we're running at the moment that's not the case. So I think we're alright. But in some of the other tests we ran we did have that bit set, so, and we didn't see any problems, so I'm guessing that solder bridge wasn't a full bridge, maybe just a high resistance connection, or maybe just a false alarm, but I'm glad to have solved that anyway. Okay, let's have a crack with those fixes. I don't want to speak too soon. And we've got the odd behaviour on DI over here as well. How are the power lines looking over here? Looks perfectly healthy. You probably can't see that screen. Now the only thing that should be able to affect these LEDs here are going to be the load, increment or decrements. One thing we did do is swap these boards around and basically shuffled them. Let's put a different one in there. So swap these two. Okay, so this is behaving, this board was up there and it's behaving exactly the same. So that implies these inputs are going a bit rogue. Right, what else could we plausibly isolate? These three lines are selecting which board is asserting to the address bus. Right, so I'm going to hardwire this to 1. Okay, I was expecting the program counter to be completely solid. That's because that's not that line. That's the address select. Right, that is totally consistently getting the same character, even running at max clock rate. And we're not seeing any weird increments over here. I'm not 100% convinced still I've got a problem here. I think I may have a problem that's been there for longer and it only shows up with more stuff connected. I've got to be careful of those pull-up resistors we found over here. All it would take is a line driver to isolate them, but I don't think that's our problem. What I want to do next is go and look at all the soldering work I did underneath these boards and double check all of that. So, big disassembly again, but that can wait till tomorrow. Okay, so I've still got the address register select onto the address bus hardwired to the program counter. And I actually left this running for a while and it's been completely stable. So I figure we've either got an issue with bus control, but the other thing that we could potentially discount is that the problem could be related to the specific number being asserted onto the bus. So I think it's less likely to be that, but I want to knock that out of consideration before I make assumptions. So let's write a bit of code. Okay, let's switch the LCD into 2-line mode, which is actually 4-line mode on this device. Right, character 32 should be a space. Then let's just ink A. We should be able to put out 40 different characters. Actually, we'll fit 80 on screen. That'll be a big chunk of the character set. Right, let's give that a go. Seems to be working okay. We've got a double @ symbol. Okay, I was curious, we did see a problem there. Yeah, I saw a double character right there as well. But then I am round here touching wires. Oh, of course it's not counting to the limit because my increment of A is overwriting the 0 flag from the decrement of B. This does make me a bit more suspicious that we've got a couple of minor issues that are summing up to be a bigger one. That shouldn't have any effect because the current code isn't changing the address at all. That's curious, we got the same double @ symbol. we got the same space there. I think this could actually be related to specific characters. That's 3F and 40. I'm putting in both the question mark and the @ symbol because obviously it could be the character before. Actually, I suppose it could be the character afterwards as well. So the A is always doubled. Now we're getting somewhere. Oh, so I actually did. I had the extra out LCD data comma A left from the string copy loop, so this isn't actually doing the wrong thing. Right, so we were seeing some odd behavior on here when it goes wrong, but only intermittently. And at this point, the worst problems we're seeing seem to be when we switch to SI as the memory read location. But we only actually get the problem if the transfer register full board is here. It does make me think how sure I am of the connections that these pin headers are making. So that one's quite loose. Right, I want to check the underside of these boards a bit. Okay, I'm going to fast forward through this. I visually inspected it all and tested it all with the multimeter to make sure everything that should be connected was connected. I couldn't find any problems. Some of this Vero board stuff does look a bit rough though, because it's very difficult to keep the solder joints neat. It can flow down the tracks a bit. Okay, I'm taking a look at the bus control board. It has occurred to me that I never actually cleaned this PCB. Okay, that chip, very slightly in the air, looks like I've got a solder connection on everything. That is main bus assert, not one I'm particularly keen on being questionable. Right, question is, what should I do about this? I'm going to be honest, I'm getting uncomfortable about how much browning I see on the board here. I'll just do this with the soldering iron and make sure they're connected. let's put this thing back together. Well, that's doing what the code in the ROM says to do, so I haven't messed it up anymore. Okay, now that appears to be working, but we're still seeing the unexpected increments over here. Let's see how it looks today. Right, it does feel like every time I turn this thing on at the moment I see something different over here. Sometimes it's almost perfect and sometimes it's way off. Of course I'm moving this all around slightly and whatever's loose is probably getting shifted each time I move the boards. But one thing that's very consistent, and that's what I want to look at today, is this odd counting over here. Now I did swap these registers around a bit and we always see the problem on whatever in this space here. So I kind of wish that I had something where I could really spot what was going on with these lines. But I want to take a look at the circuit board and see whether or not we can suss anything out. Okay, so it's DI here, and the problem looks like it's incodec. There's a very long line. Right, so if we assume this line is going wrong, it doesn't tell us why these avers aren't going weird. What's that connected to? Hang on. We've got a floating input here. Okay, this is curious, and this is a little bit of an embarrassing mistake. If you remember, on the breadboard version of the bus control, I had these two clusters being handled by a single 139, which is two separate 2-line to 4-line demultiplexers on one chip. But there wasn't a HCT surface mount version of that, so I split it up into two 138s. But of course, the 139s had two inputs, and when I've split it up, I haven't set the third input. Now that could definitely explain what we're seeing on that line. Floating inputs on CMOS chips is not good. Actually, before I do anything else, let's fix that. Right, so pin 4 is already tied to ground, which is what we want. So in terms of bodge wires, that's a lot easier than it could have been. Right, I should do this with a nice and obvious bodge wire as a permanent reminder to check my wiring. I think I'm getting close to needing a new tip for this soldering iron. Right, I have never done a bodge wire like this on surface mount. Could of course just do this as a deliberate solder bridge. Okay, well the solder bridge is doing all the work there. But of course the wire is as much there to remind me what's going on whenever I look and see that solder bridge. Well, that's not pretty in either case. Those lines are definitely tied to ground. Okay, well I'm not going to make any bold statements about this definitely being the problem. And it wasn't. Okay, I did have high confidence for this because a floating input would definitely have been a compelling explanation for what was going on there. Okay, I'm going to go back to my earlier point. I very much want to know what's happening on these lines when these counts are happening. I've got a feeling that's going to be the thread that if we pull on it, we're going to unravel all of the problems. And so much of this has to be working exactly right in order for us to get anything like the correct text over here. In some ways, I shouldn't feel too bad. Right, I'm going to call it a day and edit this up into a video. There's obviously some more troubleshooting that's needed on this, but I'm very conscious I haven't put a video out in a little bit longer than normal. So I'm hoping that you'll find this interesting. In some ways, this is actually really rewarding for me because I've had an awful lot of stuff that's just worked first time, and kind of digging around trying to understand what might be going on here. I've been doing quite a lot of reading. I think I've probably added more to my electronics understanding in the last week than in kind of the 2 months before then. So there's hope. I'm confident that this is going to be working again fairly soon. Well, I'll be back quite soon with another strategy and hopefully we'll get a bit further. Hope you found this interesting. Thanks for watching and goodbye.